Well, good to have you guys here today. So the first part of here, I'm going to go through basically the last 30 days, and there's been a lot of giant news within the AI industry, and we de-geekify it a little bit so that way it isn't all ones and zeros and such. But here are a bunch of stats on AI models. The first one we're going to look at is AI hardware. Specifically, you can see the year that each of these different hardware components were released, and these are NVIDIA, which is the 800-pound gorilla within the AI industry right now. But you look at the year that it was released, and over there, you'll see under GPU memory bandwidth, you'll see that number go up and up and up year over year. Now, those GPU bandwidth, and that's the fourth column over. The GPU bandwidth is the actual horsepower that all these models are being trained on. And a model, just like Ford releases a new truck every single year, these AI companies, whether it's OpenAI, Anthropic, Grok, or any of the other model, Mistral, they're releasing new models. Every model has new features, new bells and whistles, new capabilities, sometimes it's more powerful. The hardware, which is like the actual physical computer components, are what allow them to train larger and larger models. So they find new ways of doing things as well as they gain more power. And from here, you can see it. This is exponential power increase from a raw power perspective. It's not like they're making a 10, 20% improvement. You're seeing doubling, tripling. Last month, NVIDIA released what's called the B200 chip. Now, this one, 20 times, it gives 30 times performance on a lot of these models. So that's a tremendous improvement. So like ChatGPT and all the models we have now were trained on what's called the Hopper models, or the Hopper chip, which you see as about 4,800 GPU memory bandwidth. And don't get too concerned about what GPU memory is. Just look at it as a number, just like you would horsepower, volts, anything like that. Well, the Blackwell model doubled that almost. Easier graph to see. Where in 8 years, we've had 1,000 times percent improvement in raw power of these AI models from a hardware perspective. We're not talking software. We'll get into software in a second. But this is just straight up hardware capabilities. The more capabilities you get these AI engineers, the much larger models you've seen, which is why in like the last 3 years, you've seen things from, we first got our first text to image that looked pretty decent to now they're doing text to video that looks realistic in a matter of 3 years. But over those 3 years, you see from 2020 to 2022, you had huge improvements. Now, 2 weeks ago, the NVIDIA just released the Blackwell, which has a 5 times improvement there. What they have done with these, this is the specific model of OpenAI. ChatGPT, many of you guys have probably heard of. In fact, most of the time when people think AI revolution, they're thinking GPT, and specifically GPT 3.5 is a reference of which came out in November of 2020. Now, GPT has going numerous years. The far right there, the context token window, is basically how much stuff you remember. And these AIs are gaining capability of just remembering your inputs. It's not just the stuff that they were trained on, but it's the actual stuff that they're able to remember. This Claude came out this month, Claude 3. Here, these are the improvements that this company started last year, March of last year. So OpenAI has been working on 6 to 8 years building their model up. Claude, according to all independent research right now, exceeds ChatGPT 4.0 in capabilities. And we'll go and play into that. This Claude model, I was actually able to build 3 software applications this week with 100% Claude coding, where I didn't do any coding of it. It did all the coding. It integrated in my APIs. It researched the APIs for me. It built the front end. It told me how to build the server. It told me the commands to do it. And when I got errors, I put the errors in there, and it fixed the errors for me. And one of the tool I'm going to use for you guys today to show you how to use the AI was built by Claude. Which is, again, just like, obviously, in this world, Chevy would be the Claude because it's the best one. I got my friends down there at Kai Chevrolet.
You suck it up hardcore and
I do what I can, right? This here shows the model progression in power, and you see that's quite an elevated line, correctly? That's year over year, we're seeing huge improvement. GPT-1 capabilities, GPT-2, and it keeps going up. But what's most impressive with this graph is that this graph is not linear. If you look on the far left, each of these are to the power of 10. So 10 to the third power, 10 to the fourth power, year over year, It's not just growing like that, but it's growing exponentially to the power of 10 from the capabilities. And that was with hardware that is 20% as powerful as this year's AI developers will be able to build their new models with. So we have more compute, larger systems, and capable of creating more creative models as a whole. AIs, especially in the last year, have transitioned over from being, especially for the general user, from being something that you build a text prompt with or an image prompt. They're moving into the knowledge of everything. I'll show you some of the capabilities, and particularly in the world of robotics, which allows you to have a real world environment view of everything that you're seeing. Modern robots nowadays are not being coded by software developers, at least the ones that are coming out there. Tesla 12.3 just came out this month, and now Elon Musk this week said that every new Tesla, they're going to require the salesperson to go for a ride to show the new self-driving capability. They haven't made any major progression last year because they completely rewrote their AI system. Their previous one was written by human developers that use AI inputs. This new one is front-to-end neural link capability. That means that the AI is coding the AI and training the AI on how to interact with the different real-world environments. And in a matter of 1 year, they gained parity with their AI system that had been developed for 10 years. And now it's starting to exceed it as they work their way towards full self-driving. But that's because they create these digital worlds that you can do 1,000,000 years of testing in a matter of a second with a supercomputer, and then whichever AI model did the best, that gets put into the AI as a whole. Over to humanoid robots, because that's where a lot of this is starting to move into, that these humanoid robots now are training themselves with real world environments, doing real world tasks. Because as they get more processing power, more raw power, they're able to get much stronger models that can do much more than text, video. They can actually interact with your real world. This here was 2 weeks ago. NVIDIA is empowering numerous, these are all robots that are currently being developed right now and anticipated to be for sale in 2025. So next year. Ranging in price from $20,000 up to $150,000. Not humans to develop it to do a task, but using AI models to do the task. And not just one or two, literally thousands at a time. I'm going to show this video here.
Hi, my name is Jer. I'm going to teach you how to use Baxter, which this is Baxter. How to use.
So this here is my son, who's actually over in the main center over there right now, helping with tickets. So what he's doing is basically showing it the action he wants it to do.
All right.
He was programming it. And at the end there, it'll actually run through it.
Still doesn't like it, so I'm going to reset it.
All right.
And make a new program. Now it will do exactly what I told it to do.
But it's a little bit grainy because, again, that was from 2016 and by an 8-year-old. So the robots, from the robotic perspective, were more than capable back then. It was just the labor time it took for it to do simple tasks was exceeded the value to businesses to actually make it do those tasks. So the training of it, the interacting with the real world, those were all tasks that were just not efficient. Now let's watch this one. This one came out this month. Something I want you to see in this robot here, you see powered by OpenAI. That's the ChatGPT model that you guys have been used at, and it's been the 800-pound gorilla from a text perspective. OpenAI is now advancing itself that they're allowing their service to be integrated in to humanoid robots. So that way, rather than like you saw my son going and teaching it how to, you just tell it what you want it to do. And it uses its AI, much like it used from a text perspective, to then understand what does this person want me to do within the real world, and then it programs its own movements to perform that action.
Hey, figure one, what do you see right now?
I see a red apple on a plate in the center of the table, a drying rack with cups and a plate, and you standing nearby with your hand on the table.
Great, can I have something to eat?
Sure thing.
Now, all of those movements were programmed
Can you
by
explain
itself.
why you did what you just did while you pick up this trash?
And the reason from this demo perspective, he randomly throws trash on there is to really nail down the point that that trash was not pre-planned. This is one continuous video. They didn't interrupt it. It's all one continuous action. And this means that the robot is seeing the trash, identifying what needs to happen with it, and then self-programming itself on what actions its arms and legs need to take in order to accomplish that goal.
Crash?
On it. So I gave you the apple because it's the only edible item I could provide you with from the table.
Great. So, based on the scene right now, where do you think the dishes in front of you go next?
The dishes on the table, like that plate and cup, are likely to go into the drying rack next.
Great. Can you put them there?
Of course.
All right. So, how do you think you did?
I think I did pretty well. The apple found its new owner, the trash is gone, and the tableware is right where it belongs.
I agree. Thanks, Figure One.
Get my teenagers to do this.
Yep. So the next component here is that these humanoid robots, much like anyone here who's even looked at the pricing of robots before, know that these things are normally hundreds of thousands of dollars. Tesla next year has announced that they want theirs for sale for $20,000. $20,000. They're leveraging their internal, fully redeveloped Neuralink. So they have their self-driving cameras in the head unit of it. They have what they call their dojo training, which is the same component as those that NVIDIA training. These are just two different companies that are doing the same process for the training of these models. That humans aren't sitting there coding like, all right, how do I need to make the arms move, legs move, fingers move? How do I choose which action I'm supposed to do? It throws it into dojo, processes it, and then accomplishes the goal after they have created a real world map of what's happening. More importantly, Tesla specifically is building their robot so that way the robot itself is built by humans. Because theory on this is that their robot is going to be built and assembled by robots so that way they can infinitely scale it. They don't need gigafactories and presses to go ahead and assemble the robots. All they need is open warehouses and tables, and they can, as long as they build more robots, they can then build more robots. And they want to get up to 1 billion robots a year being sold. Is their market goal. But they're allowing this to be done by bigger, faster, stronger, and cheaper. You know, the AI processing power is going through the roof from a processing power. Without that processing power, these accomplishments can't happen. It's impossible for them to move forward because because they're being developed and coded and tested within virtual environments. So you don't need to have research and development to see does this thing actually work. They fully test it in the AI environments. And because we have these processing power, and as you see these scales, none of these scales look like they're leveling off, right? Next year, NVIDIA should release a 2 to 5 times as powerful processor as the one we're seeing today. Numerous models, even just this morning, Elon Musk, his AI is called Grok. His Grok one, they have 1.5 coming out. He just open sourced 1.0 last week, and in benchmarking, it's on par with ChatGPT. Now, ChatGPT isn't anticipated to have something very significant that they're about to release, which is going to supposedly blow all these models away. But from a future projection, there's nothing in the data showing that this is anywhere near slowing down, only that it's going faster and faster and gaining more capabilities year over year. Tomorrow's robots won't be on our computer screen. They're going to serve us coffee, fold our laundry, and cook our food for us. Yes. In fact, that Tesla robot, they have video of it folding clothes. Primary, from a use case perspective, it's one of the most difficult tasks because you have a soft fabric that needs to be very precisely performed. And to have the AI code itself on how to fold a shirt is a very huge account. Because if it can do that, it can stock shelves for us. It can go ahead and flip a burger. And these are general purpose. They're not specifically purposes for flipping burgers. It's a robot that can walk up there and just do the general tasks that you verbally told it to do.